and cosine. But we're not going to write as much as I typically do because I want us to get on through this and be able to translate. Folks, it's just like translating any other function. If I gave you this function, quantity x minus 1 squared, quantity squared, plus 2. First of all, you have to be able to identify what kind of function that is. What kind of function is that? It's a quadratic. You have to know what to do with that. What would you do? What kind of movement?
Up to what the right one.
Do you guys agree with that?
Yeah.
Okay, so it's up to left 1, right on?
Right.
Okay, so left 1, up to, is it opening upwards or downwards?
Right.
Did you say left? Did I say left?
Yes.
You said right?
Yes.
Okay, my bad. See? Pepper, salt, pepper. Now I feel better. Okay. I don't know why that happened. You said right, correct? Okay. I don't know. Opening upwards or downwards? Upwards. Okay. So this parabola is going to look something like that. We could make it more specific if we were to graph what? The x and y intercepts. Would there be any x-intercepts for this? Probably only going to be one y-intercept, correct? But we could be very specific with this if we wanted to be. What's the domain and range of this function? Domain is all reals. What's the range? All rails. All rails greater than or equal to positive 2, right on? So all of this stuff that we study, it still comes back and we have to revisit it and we have to think about it. And we just keep using the same information about domain, range, intercepts, yada, 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 right? So how does this pertain to sine, cosine? Sine. The sine property, the parent function for sine of x, we are typically only going to graph one period, which is one cycle, one revolution of the curve, okay? The only revolution that we have any knowledge about right now is what? And you take daily quizzes on them every other day. The unit circle. So we know that it's going to start where? At 0, and when it makes one complete revolution, it's going to rotate to what radian measure? 2 pi. So our parent function for sine is going to be one revolution on paper, okay? And this is sine, folks. There are key points that we have to observe. For the sine function, it will go no higher than 1, and this is specific to the parent function, okay? We can do things to the function to make it taller, but for the parent function, it will go no higher than 1, it will go no lower than -1. And it's going to go up with the maximum value, it will pass back through the x-axis, down through a min of -1, and then back up to 2 pi. It has to be smooth and beautiful. I better not see this right here. That is a mountainous valley. That is not true. Okay? I don't want any sharp points. Smooth and beautiful. What do you think the midpoint is going to be? And you already have it graphed from last night. What is it? Pi. That's 1/2 of the revolution. Well, what's the maximum value going to be? What's the x value when that curve hits that maximum y value? What's half of pi? Pi over 2. What's the minimum value? What's the y? No, what's the x value when that sine curve hits its minimum point? 3 pi over 2. We had to talk about this ordered pair for this maximum value. What would that ordered pair be? It's going to look funky, weird.
Pi over 2 and 1, is it?
That's exactly what it is. The maximum value is pi over 2, 1. What is the minimum value, everybody?
3 pi over 2.
Right on. That's our minimum value. Okay, folks, isn't that common sense? Okay, you know how to find ordered pairs. Now, we will only, a period, we will only graph one period, which is one cycle or revolution around the unit circle. That's really all I am concerned about, okay, is just from what's going to happen on the parent, on a normal graph, what's going to happen from 0 to 2 pi, okay? How you feel?
So what's the amplitude?
We're not there yet. No, hold on. We're getting there. We're getting there, okay? So if we talk about the parent graph of sine, of course we have to talk about the parent graph or cosine. Let me bring up something about sine though, now that I'm looking at it. Notice where it starts. It starts where? Sine curve will always this is the non-moved, non-translated sine curve, will always start at 0, 0, at the origin, okay? Positive sine curve notice that it always goes up and then it goes back down and then back up, okay? The sine, the positive curve goes up then down. You see how it goes this way, okay? And do you see how it's kind of sort of symmetrical? The same shape occurs between pi and 2 pi, but it's on the negative side. So it's kind of symmetrical, but not. Just think of it though, it's the same pattern repeated. Let me think if there's anything else I can. We'll always start at 0, 0. Hey, it will always start and end. Excuse me, thank you. We'll always start and end on the x-axis. Okay? For the normal parent function. All right? So that's kind of the nuts and bolts of sine. Let's look at cosine. Are we ready? Okay? Everybody good? Just another minute. Y equals cosine x. Again, same type of picture. It's going to be heavy on the positive x side. 1 and -1 are very important to us. But when you look back at your graphs, y'all, where did the cosine curve start? Sine starts at the origin, but where does cosine start? It starts at 0, 1, doesn't it? So it starts here, and then what does it do? It goes down and then back up. Now, I always draw my curve for cosine, and then I go in and I put my values. One period or one revolution would be from 0 to 2 pi. What's going to happen halfway? What's going to happen at pi for the cosine curve? It will be the minimum value of this curve. Okay, what's that ordered pair, Omar? How far do you go over? You go over pi, and you go down to -1, right? That's your minimum value. Where are those x-intercepts occurring in?
And 2 over 5 2.
This is occurring where?
Pi over
This first one is at pi over 2, and the other one is at 3 pi over 2. Do you see how those quadrantal angles, do you see why I covered those first? We keep going back to them and back to them and back to them, don't we? Okay? So what did we put here? Because I always like to have everything parallel. Where does cosine start? Where does it start? Cosine always starts at 0, 1, doesn't it? And where does it end? It ends at the 1, it ends at the same level it started, didn't it? Do you see that? You don't have to draw that in, but do you see how they both end at the same, they start and end at the same height? Yes? Okay, you don't have to draw that. Now, always starts at 0, 1. Or let's put that it always starts and ends at y equals 1. Always starts and ends. And that's only if it's positive. A positive sine, cosine curve. Positive cosine curve. What does this resemble? Because how are you going to keep all this straight? What does it look like? It kind of does look like a parabola, but I'm even going for more, I'm going for like first grade. I ain't even thinking math. What's that look like? Cosine. It looks like a cup. Cosine looks. Like a cup, doesn't it? There will be times that I will say, folks, is it an up cup or a down cup? Why would I ask you if it was a down cup?
Negative.
If it's a negative cosine curve, it's going to look like a down cup, okay? And once we start graphing these, you're going to be like, oh, okay, I get this. What does the rewind. What does the sine curve look like? If the cosine curve looks like a cup, what does the sine curve, is your imagination?
Snake.
A snake. And it is, you know what? No, Morgan. It is 2 cups. It is piece. Guys, if we looked at, where is it? If we looked at this much of that curve, what would it be? That's a down cup. It is, the sine curve and the cosine curves are just shifted curves. All that changes is where they start, okay? It's the same shape, they're just shifted side to side, okay? You're exactly right. It is 2 cups, but I think of sine, snake, go up, then down. Cosine, cup, up, cup, down, cup. Are you with me on that line of thinking? Can you wrap your head around that a little bit, maybe? Does this seem so bad so far? Are we feeling okay? All right, so let's look at some other things. General form. Just so you know, if you're ever on math team, if you're ever on Jeopardy, the sine cosine functions are called what's that word?
Sinusoidal.
They're sinusoidal functions. Yes. Write it down. If you're ever on Jeopardy, folks, I'm in the business of saving lives, and I'm trying to help you. I'm going to help you now, that when you're 26 and you're on Jeopardy, that you win millions of dollars. You may remember your junior year math teacher, Jimmy, and you may say, you know what, Beat, I'm going to help that lady out, because she is driving that old raggedy hover around, and I'm going to buy her a new hover around, and it better be blinged out, Beat. Jimmy, you hear me? You better pimp out that hover round. Okay, that would be even better, wouldn't it? But how cool would that be for me to ride around in a hover round? I'm telling you, it would be.
You have to call them on the first day.
If I can remember,
He will flip out.
I will call roll. Yes.
Just go ahead and write
I'm
it
not
down.
gonna come in here. What block do you have?
First,
Alright, I'm coming in.
Motivational Monday's just not going to be the same.
can't
Walk
let
in
them-
Wednesday.
You can't let them have videos yet.
They can make up their own.
They get videos later like we do.
Okay. Y'all remember this when y'all are all teaching high school. Teaching high school. You remember this when you all have a litter of children years and years and years down the road, please.
How many is
I don't know, six, four greater than or equal to 4. Litters.
And what if it's like 3.5?
That would be, we're gonna visit you and we're gonna love you anyway, Philip, and your little half child. A litter is greater than or equal to 4. Okay? It's always tied back to math, y'all. See, I can make math into anything. Look at this general form. Folks, sine, it's sine or cosine, either one. The form doesn't change. But either one, it's going to be A, the function, times the quantity, bx plus c, plus d on the outside. Does that kind of sort of look familiar? It is in alphabetical order. That's for a reason. What's it kind of look like? It kind of does look like the mx plus b stuff, doesn't it? Mx plus b. That kind of looks familiar. Does this piece right here kind of look familiar to this? Shut up, just does. Kind of sort of does. Except for this quantity is squared. That's the difference between a quadratic and a sine or a cosine curve. Okay? So that I can kind of see the similarities, and if you can connect to something you already understand, graphing these will be a whole lot easier. Okay? Now, check this out. Y'all crack me up. I love this class. And I'm not just saying that. I really do love this class. No, I don't say that to everybody. I love every class at some point. At some point, but this is an everyday love fest. This is the best. A. Omar, what's the A stand for? You asked. For it earlier. And this is your answer. Amplitude. We're going to look at we're going to look as much as we can today. And we're going to start graphing. Just have to have a little bit of background information. Amplitude, what is amplitude?
From the top to the bottom.
It's going to make the function makes the function or curve stretch vertically. This is when they get really, really tall. Okay? That's what affects the height or the distance, the vertical distance in the curve between the minimum and the maximum. The maximum and the minimum. All that points on that curve. Okay? The other thing that we are going to, and I'm going to go ahead and tell you what they are. The B. Okay? Of course, this goes for cosine as well. The B, where's the B? The B is the period. The length of the curve. And folks, the period is equal to 2 pi over the absolute value of B.
It'd be like more than one, so.
It can. Or it can be, yes, meaning it's going to be more than one revolution. It doesn't even have to be one complete revolution.
So period would be like 4.
Yes, it can be. Yes, absolutely. We will graph things that have a period of 8 pi. We will graph things that have a period of pi. Okay, just what's happening to the curve for half of a revolution. And you'll see. You know, you'll see. Just hold tight. You'll see. The C, no pun intended, the C value is the phase shift. Folks, this is just the horizontal shift. That's the left and right movement of the function. And then the last, D. What do you think that's going to represent? That's a vertical shift. If it's plus 3, of course it's going to go where 3? If it's plus on the end, if the vertical shift is plus 3, where's it going to go? Up. If it's minus 3, of course it's going to go down 3 units, right? Everything is based around the oscillation line. That's another big, I'll say that 500 times. Oscillation line. For the sine curve, this is where the curve, this is a, this is a dotted horizontal line that we're going to draw in. Everything to me is based on the oscillation line. Once I figured this out, graphing these things became a piece of cake. But it's a dotted horizontal line. For the sine curve, it's where the curve starts and ends. For the cosine curve, it's like a midline for the curve. For that up cup or down cup. And it being a midline, a mid horizontal line. Okay? That's a whole lot of information, y'all. That's a whole lot of background information. X. Okay? And we're only going to graph one period. The pre-work consists of this. We're going to write the same things all the time. Is this thing going to reflect? Is it going to reflect? It's a positive 5 sine x. So it's not going to reflect. Now, I always, just for me, I just write myself a little note that I know that if this is a sine curve, it's going to look like a what? A snake, and it's going to go up or down if it's not going to reflect. It's going to go up and down and up. So I draw that a little tiny little picture. So I know that when I graph my curve for real, that it better go up first and then down. Okay? The second thing that you have to include is your amplitude. What is the amplitude of this? 5. So what that means is from the oscillation line, it's going to go up 5 and down 5. Okay? Does it have a, what was the B?
Period.
Does it have, well, it does. Let's look at that again. It's the coefficient of the x. Well, what's the coefficient of x? 1. 2 pi over 1 is 2 pi. So we only have to graph from 0 to 2 pi, right? Does that have a phase shift? There is no phase shift. Does it have a vertical shift? No. That's the pre-work I'm talking about. Every single time. Every time. Does it reflect? What's the amplitude? What's the period? Phase shift, vertical shift. You'll have to fill this in every time, okay? For your homework, if you don't, it's not going to be complete. I'm telling you now. If you just graph it and you're done with it, fine. Well, that's fine, but you'll get half credit for that problem, okay? So this is half of the work. The next piece. We're going to graph this thing. Where is the oscillation line for the sine curve? What did we write earlier?
Where it starts and ends.
Where it starts and ends. This one has no vertical shift, so we're not moving it up or down, so it's got to start where? It's going to start at 0. So what I'm going to do, just because, if I had a colored pencil, I would use a colored pencil. But since I have a highlighter up here, I always highlight the oscillation line. I know that this curve is going to start and end on the oscillation line. It's going to go up how many units from the oscillation line? How many? 5. It's going to go up 5 and down 5. And then, folks, all you have to do is draw the curve. And this is what you do. You watch. Okay? Put your pencil down and just watch for just a moment, and then I'm going to let you go back and graph it. Okay? So it starts here. My picture says it goes up first, so I'm going to go up to 5. I'm going to come back down, and then back up.
How do we like go until we make it possible?
It just as long. That's why. Did you notice that I put my starting and my middle point? Make sure that when it crosses. All right, hold on. What's the first y value of my curve? 0. What's my last one? 2 pi. I know that it's 2 pi because that's the period of my function. Okay? What's the halfway point have to be? It has to be pi. So when you get ready to cross the x-axis, make sure that you are getting ready to go through the axis. Okay? That way our maximum value will occur when x is what? Pi over 2. And my minimum value, folks, should occur when
3 pi.
x is 3 pi over 2.
Will it always be the values?
No. When we have a phase shift. For today, yes. For, no, maybe not. It might not. It might change. But it will be easy enough that we can figure it out. Okay? What do you think about that? It is very simple. It's very, very simple.
What would be the order pair for the max and minute? Oh, you need to know that.
You don't even need it. If I asked you just for kicks and giggles, what would the maximum value be? Maximum order pair.
5 over 2.
Pi over 2, 5. What's the minimum value? 3 pi over 2. Negative 5, right? Just, I do not require you to write that on there. But for kicks and giggles, that's what they are. Facile or difficile? Or
So really all you're
facile.
doing is looking for that beginning number to show where your curve goes, really.
Yep. And once you lock in the fact that everything's based on that oscillation line, it is a piece of cake. Piece of cake. Can we do another one? Here's another one. Have to do all that pre-work, bad as we don't want to. Hey, let's do this one. One half sine x. Don't flinch. What's the first thing? Is it going to reflect? Ooh, ooh, ooh.
Yes.
How do you know?
Are you good for the wall?
Because it is going to reflect. So if this is the sine curve and it's reflecting, where's it going to go first? It's going to go down, up, and down. Right?
Why does the other one reflect?
Because it was positive 5.
Isn't it reflecting
No.
then? Why is it? Why is it when it's upside down? It reflects?
Because it is. Based on the table of values from yesterday. Okay? Amplitude. What's the amplitude of this one? Well, you know what? Let's go back and fix something. Amplitude, folks, is the absolute value of A. So a distance can never be what? Negative. It can never be negative. It's the absolute value of A. That's an easy fix. So the amplitude of this is going to be the absolute value of negative 1/2, which is 1/2, period. What's the period of this? 2 pi over b, which is 2 pi over 1, or 2 pi. Will the period always be 2 pi? No. Do you know where that 1's coming from?
I don't know where that's from.
Right here. Your b.
How do you get into
Because that's part of the, wait a minute. That's kind of part of the definition, if you will, this right here. It's 2 pi over the absolute value of b, okay? Amplitude is the absolute value of a. Got it? All right, what's the next piece? Period, phase shift. Is there any phase shift? No, there's no set of parentheses, right? So there is none. Is there any vertical shift? Is there a value that's been tagged on the end, plus or minus a value? No. So there is none. So life is good. We get ready to graph. Where's our oscillation line for this?
the midpoint?
It's what? Be more specific. Not 0, 0, be more specific. The x-axis. Okay?
Or y equals 0.
Yeah. Draw your oscillation line. Now. Shoot. I'm not being taken. 1, oh Lord. -1. Are you cool with that?
How did that happen?
Why is it 1?
Well, I'm just putting 1, but how am I going to graph it? I'm going to graph it up to a half and down to a negative half, right? And where's it going to go first? It's going to go down first. So I've got to put 0. Where's it going? 0 to where?
2 pi.
To 2 pi. You said it's going to go down first a half, then back up to a half, and then back down. Go back and look at it. It is kind of lopsided. It'll do.
Mine's really not.
You know a way I fix that? That right there. That's why I can fix it.
Is that okay if they like mirror point 1/2?
It is okay if you did that. But I just wanted you to see what would happen. What's happened to the curve? It's kind of like I'm making the string more tight so that it won't, so it loses slack. Does that make sense? When I put it together, it's like I'm giving a lot of slack. So there'll be a tall arch, but when I pull it tight, it's like I'm taking out the slack. Now, where's it passing through? It's passing through at pi. What's the minimum value of this one?
Pi over 2.
Pi over 2. And my maximum value is 3 pi over 2. Guys, are y'all with me on this or no?
Yeah.
Is this easy? Yep. Stop playing. I have to tell myself that. I want you to do this one by yourself. Everybody ready? All of your information. You do the pre-work and the graph. Just in case, make sure that you've got these values. Make sure, and I'm being nitpicky, okay? Make sure that this is going to hit you about here. Okay? Make sure it's right. I would line them up with the lines on your notebook paper, okay? You don't have to do graph paper, but at least line them up with the lines on your notebook paper. Here, does this thing reflect? No, it's going to be an up cup or a down cup. This does not reflect, so it's going to be an up cup. Remember, your oscillation line is the midline of that curve. Just remember that. What's the amplitude of this one, everybody? Absolute value of 2, which is 2. The period is going to be 2 pi over 1, which is 2 pi. Is there a phase shift? No. Is there a vertical shift? No. Okay, we got our pre-work done. It takes 5 seconds, 7 seconds at most to write that stuff down. Big deal. Oscillation line is the midline. If there is no vertical shift, the oscillation line is still going to be the x-axis. And I don't have a vertical shift. So my oscillation line is going to be the x-axis. Now, this thing's going to go up to, and it's going to go down to. Do you guys agree with me?
Start to,
I can squeeze you. Say it again.
start to,
It's going to start at 2. Where's it going to end, Corey? It's going to end at 2. Bless you. What's the minimum point going to be, y'all? -2. And where's it going to be? You kind of have to eyeball this. So I got to stand back. It's going to kind of be at the middle, right? So we're going to kind of go to the middle at -2, and you are not going to draw a V. You are not going to do it. If you do, I'm taking points off. Not to be a hateful, but maybe to be a little hateful. But I want it to be up cup or down cup. It's got to be an up cup. It has to have some curves. Look at that. Okay. Where did it start? What's the x interval for the starting point of that function? 0. What's the end point? 2 pi. What's the minimum value of x? And the x-intercept is pi over 2. The other x-intercept is 3 pi over 2. How about them apples?
Like green apples.
Okay.
The grains.
Granny Smith?
I like the yellow ones.
No, what's
The
the
red
big
ones are like mushy and
what about the big apples?
I like the Honeycrisp
Yeah,
ones.
same as the one.
Galas?
Oh,
Rome's?
big, that couple good.
Are they
Are they
red?
sour? Are they sour?
Are they red? Okay, he's having a seizure.
Are they sour?
I mean,
Okay.
I like the
Pepper,
sour.
salt, pepper. That is our new code word for get back on task. Pepper, salt, pepper. Here we go. Who said that? Can we do another one? Heck yes. It's about to get crazy up in here. Get ready. It is about to get crazy.
We haven't got the period there in the morning yet.
We sure ain't, but it's gonna get crazy. You know what? It's gonna get crazier.
Wow, boy. You gonna make it?
Oh, uh-huh. Everybody say thank you, pepper, salt, pepper. Thank you, pepper, salt, pepper. Okay. So we got a whole lot of pre-work. Okay. Is this thing gonna reflect? Yeah. So is it gonna be? What's the curve gonna look like? It's gonna be a down cup. Make sure you draw your imaginary little oscillation line in the middle, because that's just like a note to self. What's the amplitude of this thing gonna be?
4.
Absolute value of 4, which is 4. What's the period gonna be for this? Hold up. It's gonna be 2 pi over the absolute value of what number? 2. Never fear. We got this. 2 pi divided by 2 is pi. So the length of that curve is going to run from 0 to pi this time. Or will our intervals change this time? Our x intervals will change this time. Just keep that back here. Is there a phase shift? No.
When
Is
there
there-
ever gonna be one?
Huh?
Is there ever gonna be one?
Oh,
When she adds more numbers, right?
yeah. When I add more numbers in there, yes. All right, so here we go. What are my y values I'm going to put on my y-axis? 4, I'm going to go up 4, down to -4, right? My oscillation line, that's the next thing I want to put in there. Where's it going to be? Same place, x-axis, correct? Guys, do you know that without me telling you that?
Yes.
Okay,
Will that ever change?
yes ma'am. Not today, but it will change. When it shifts half, when there's a vertical shift, that oscillation line will change, okay? All right, next one. Where's this thing starting? Why? Because it's a reflective. It's a down cup, y'all. Look, it has to start at the bottom. So it is going to start at -4. And folks, go on and draw your curve like normal. It's going to go up to +4 and back down to -4. You guys agree with that? And now I can go in here and I can put my x intervals in based upon my curve. So where does it start? 0. Where does it end this time? High. So what's the halfway point of this curve? And your halfway point better be your maximum point. It needs to be pi/2 because half of pi is pi/2. What's 1/2 of 1/2? pi/4. And that should be your x-intercept. So now look, 1/4, 2/4, 3/4, 3 pi/4. And y'all, isn't that based on the unit circle? Okay? What do you think about that? Are we still in the land of fossil?
No.
Is it this way? It's all right. Is it all right? We're done. You got to practice this. And you have to let me get all these drawn, get all these written, and then take a picture. What do you think BW is going to stand for?
Board work.
Board work. Okay?
That's gonna be homework, right?
Yeah.
Black and white.
Okay. Yes, total black and white with the blue ink.
Yeah.
Yes,
Blue and white.
exactly. You have to have pre-work, you have to have your graph. Okay? Here we go. First one. There it is. There they are, 8 problems.